Alright then, the title is Recreate some of the classic prototype implementations on Vision OS. My name is Satoshi. Thank you for attending my session. Alright, thank you. Alright, let me brief introduce myself. I belong to Cyber AI Productions in Japan. The company has photography studio with large LED walls, and I'm developing virtual production software. And I also hosting the developer event called Vision OS Engineer Meetup in Japan. I've always loved ARKit, and recently, finally, Apple Vision Pro was released. I'm pouring all my passion to Vision OS. And I conducted Vision OS 30 Days Challenge. I implemented over 30 prototypes. I needed to learn Swift UI, Swift Concurrency, Reality Kit, in addition to Vision OS. That was a tough challenge for me. And this has been received very well. As a result, this repository got over 1,700 stars, and it is the largest number of stars in the Vision OS category in GitHub. Thank you. I show some of them. And this is an image board, 5 by 5, 3 lines, static pictures are all located, and you can walk in there. And you can tap to make a dynamic motion. Experience this on the actual device is truly powerful and impressive. And here's a street view. I combine multiple images obtained from the Google Street View API to create a panoramic image. Okay, I can play again. That covers 360 degrees. HLS and metadata. Okay. HS video on the server is replayed, and space is dynamically changing according to the tag of the specific time. So things change as the video progresses. Okay, play again. It goes dark 5 seconds before, fireworks at 0 seconds, and back to room after 5 seconds. Yeah, this is quite fun. I also learned the metal shader. I found really cool animation in Shader Toy. So I ported it from HLS to metal shader language and ran it with CA Metal Layer. Unfortunately, Vision OS doesn't support MTK view, so I use CA Metal Layer and CA Display Link to show it. So if you want to try to do the same thing, please use this sample as a reference. All source code written in Swift, and basically there is no external library, and it's free to use. Please get the URL through this QR code, and if you like it, please give me a star. So, come back to main story. I have created many prototypes in the past, some of which had functional issues and I needed to be rebuilt. Additionally, I have recently gained new insights, such as handling word anchor. Today's objective is to share the knowledge gained during the process of resolving those issues. Then I'd like to talk with 2 topics. First, I'll explain past prototype implementations and I'll describe the issues. Next, I'll discuss how I recreated and refined it. I'll explain the changes I made. So, past implementation. Please take a look at this. This is the first time I placed the Swift UI view in immersive space. I didn't know how to do it, so I converted the Swift UI view to an image and pressed it. It's placed right in front of me with a double tap, but it seems a little bit inconvenient to use. Okay, here's another sample I created afterward. Instead of an image, I was able to display Swift UI directly. I could press a timer-like screen in space. This one was also positioned right in front of me. Yeah, I'm struggling. These two samples have the same feature. Firstly, I specify a large sphere with a radius of 100 meters as a collision component in the content entity. It looks like this when illustrated. On the reality view side, the implementation is as follows. Double tapping generates a timer view and creates a placeholder entity. And long press executes the process to exit from immersive space. I did this because the tap gesture of reality view does not fire in empty space, so it is structured in this way. At first glance, this may seem acceptable, but actually it's not. Swift UI cannot be interacted with. I mean, we cannot touch buttons in Swift UI view. We need to consider alternative methods to solve this. So the issues are 2 points. Can't touch Swift UI view in immersive space. The placement location is not clear. Object is placed directly in front. Then let's talk about recreate and refine it. I resolved issues by creating this project called My Special Timer. A blue disk serving as a marker is displayed in front of me, half meter in front of me, and if I tap it, the timer will be placed right there. And we can put multiple timers. This solves the issues previously I mentioned. Now we can interact with Swift UI in immersive space, and the placement location is clear. This seems fine. By the way, I do not think this is only one best solution. Maybe there are other good ways to achieve this. But I believe it can serve as a useful reference as one practice. I will discuss insight in 3 parts. First, placement location updates, the feature that continuously updates the position and orientation of the marker in real time. Second, Reality Kit attachments. The view developed by the Swift UI will be shown as attachment. And I'm going to explain world anchor. It is needed to fix position of entity in the space. Okay, let's start from the placement location updates to show the blue marker. Okay, this is immersive view. Reality view is used and content of make closure is empty. By the way, reality view has make closure, update closure, and attachments view builder. Animate again. Yes. Please keep this in mind. Reality view has a make closure, update closure, and attachments view builder. All right, now let's start from the empty state. First, create model entity, half meter size cube, Color will be blue as a simple material. Position is 50 centimeters to the left and 1 meter from the ground and 1 meter to the front. We can use a simulator to work this, and then you can see the box placed in this space. And let's change the shape. Let's say generic cylinder. The thickness is 1 centimeter, radius 30 centimeter. I would call this as a disk rather than a cylinder. And this is how it looks like. Let's change orientation. That disk may be rotated 90 degrees to our side. I use a quaternion to rotate this. I set pi divided by 2 on the x-axis and apply it to the orientation. Set 0.5 to alpha to make this semi-transparent. And here it looks like. It seems nice. Let's then talk about view model. At this reality view, make closure is getting longer and longer. So I'm going to create view model and process will be split into that. So let's create view model class. Add a root entity and a setup root entity function that return the entity. The meaning that we are going to maintain the root entity in view model so that the view model is easy to manage this view contents. I replaced reality view from this to this. Immersive view holds an instance of the view model. And I modified it to add view model's root entity to content. And the cylinder is now in view model. I added the cylinder entity to root view so that the view model owns the cylinder entity. Then call view model that add cylinder. And then you come back to the same scene and the same view, so it looks good. Now let's talk about ARKit. To handle position and orientation within the space in VisionOS, we need to use ARKit. I added 3 variables in view model: ARKit session, while tracking, and placement location. ARKit is the class to use ARKit in VisionOS. We want to use space information in a simple manner, so I use a while tracking provider. Placement location is an entity for placement. I added run ARKit session function, and then run this session with while tracking provider. Let's say if there are different or multiple providers being specified, then there are more information to be handled, such as, for example, hand tracking or place detection. In this time, we only need while tracking provider. And in order to update marker, I added 2 functions. One is process device anchor updates. It calls run function with 90 as frequency. What is the run in the case? This is my own method. This is how run function looks like. It's not SDK function. This is my own implementation on view model. It's an infinite loop until you cancel it. Within this loop, the specified function will be repeatedly executed at a specified interval. By the way, I was not sure if I can do this or not, because this has infinity loop. But I found this code from Apple's sample, so I thought this is okay to use it. Yes. So I decided to pursue with this approach. every second 90 times, query and process latest device anchor function being called. And inside, what you see is query device anchor being called from word tracking so that you can receive information about the current device location. We calculate an offset of 0.5 meter ahead in the direction of the camera by setting negative value on the z-axis and set to placement entity. And I made some modification to add cylinder. I changed the name to add anchor and entity added to placement location. And this is how the code is executed on Reality View. In the make closure, you can call run ARKit session in the task. You can call process device anchor updates as a build task and see how it works. Yes, according to the orientation of the device, it follows and shows the marker in real time. Yeah, we did it. Yeah. For confirmation of operation, let's try displaying something. I added a function called add placeholder. I have set it to display a red disk as a display test. And then I added special tap gesture to Reality View. View model that add placeholder will be fired. This works by tapping blue marker. You see a red disk being created. Yeah, this is very good. Yes. So in this session, I will do this thing in live code. So let's go into it. Go to mirroring. Yes, yes. Yes, maybe it's okay. Okay, create new project, my space, timer, let's Vision OS. Create it. And I enlarge it, hide the canvas, and clean up things. Okay, it's empty set. Okay, I'm gonna do define entity, model entity that has mesh and material. Generate box. The color is blue. And set the position. X, Y, Z, X to the left, Y to the up, and Z to front, and content add. Oh. And run this. Oh. that it's a simulator. Yes, it seems okay. Yes. So, change to. Thank you, thank you. So, I feel nervous now. Okay. Change to cylinder. The height is 1 centimeter, radius 30 centimeter. How about this? Yeah, doing okay. And change the orientation. I use cotanium. The angle is pi divided by 2. And axis to the x. I'm going to transparent. Oh, I forgot. This is fine. Yes, 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 yes. And then I'm gonna add the view model. Make the view model. It is observation. Also use reality kit. And this has a root entity. And function setup root entity. That returns entity. Yes. And then whole things go into view model. And this should be added to root entity. Then content, add, oh, I forgot the view model, state, view model, and call view model, set up root entity, and view model, add marker. It looks same and it's going okay. Yeah. So let's move into ARKit. Import ARKit. Add 3 variables. tracking, yeah. Placement entity. And placement location should be added to root entity. So, run ARKit session should be async. This one has to session run with while tracking and should be try and I need to do things. Yeah, I think it's okay. It's blinking, okay. So I gotta bring the cheat sheet. Cheat sheet has everything. So you remember the run function? So I paste it. And I need several extensions. And I also need this piece. Okay. CA need import quote score. So remember that we added two functions, process device anchor updates that call run, and this one calls query and process latest device anchor, and this one is 0.5 meter in front of me. So let's call this task await. Yeah, this should be fine. Oh, I know, I got a mistake. I need to add marker to placement location, and I don't need this part. Okay, following. Yes. It's too big, so smaller. And add placeholder for debug. Should be red. And entity transform should be equal to placement transform. And need to be added to root entity. And I need a components set input target component and entity generate horizon space. That should be okay. And a gesture. Spatial tap gesture. Target to any. On ended view model. So blue marker is flowing. The camera moves and tap it. Yeah, press red disk. Yes, yes. Yeah. Thank you. So that's it for live coding. So I'm gonna go back to slides. Okay, finish live coding. Yeah. So let's talk about the relative view attachments. Timer UI and the functions. I use Swift UI to make timer view. And I made timer model and timer manager. This is out of scope of this session, so please refer to my source code later. Timer model keeps the timer information, and the timer manager to handle timer-related processing. And attachments. I added view builder to attachments. I will set it up to return an attachment dynamically based on the timer model being added. The content of the attachment is a timer view. Update closure is being used to place attachments. The timer model has an ID, and the attachment is identified by that ID. Then I added the attachment to placeholder entity as a child. And this is how the mapping is done with the attachment and the entity in the space. I made some changes to the add placeholder function of view model. I just showed you the red disk last time, but this time nothing is being displayed. Let's run it. Instead of disk, Swift UI timer being displayed, and it works. It's been a long journey for me to learn about the manner of how to do this. And I was very excited when this got displayed first time. Yes. So let me talk about World Anchor. You might think it's working now. However, it depends on the position and orientation where the app was launched. Just give you an example. Next to the window, you see two boxes, but once you reset the home location, then the blue box location moved. Okay, I'm gonna play again. So blue one moved and red one stays. I lost the script. So if we leave the unanchored, then even though I located timer on desk or on the kitchen, actually it's not. They don't stay up. The timer shows up in very different location when we start up in a different location and orientation. In order to keep this situation, we need to use word anchor. And there are some manner associated with word anchor. Within ViewModel, I added two arrays. One is anchored objects, and another is object being anchored. Object being anchored is a temporary location for keeping the information. I added attached object to word anchor function. Word anchor is created first. Then we add placeholder as a temporary location, object being anchored. And then we do that add anchor to the word tracking provider. And sometimes this could have error, so we have to have an error handling as well. Oh, sorry. In add placeholder function, add to call attach object to word anchor. I added process word anchor updates function to ViewModel. That handles the flow of anchor update from the word tracking provider emits. I handle the update of anchor states in process function. This is the final piece of source code for this session. Added. When an anchor is added, I move entity data from the temporary storage array to anchored objects array. Then update. This is where the word anchor location information needs to be reflected onto a placeholder. This is where you adjust the position of entity. Remove. Once word anchor is deleted, you need to delete placeholder. By writing all these processes, no matter where the device is, you can always show the timer in the same location within the space. Let's try it. The timer is located within a space, and then let turn sideways, and then reset the home location. The timer stays the same location, just like you saw the box demo. Yes. So now let's use with actual device. So many MacBooks. Where's mine? Let me check. My PC don't appear in that place. Let's do mirroring. Yes, I found it. Yes. My special timer. I hope there's no lags. Okay, show immersive space, and there's a blue marker, and I tap it. Yeah, timer placed. I go this way, this way, this way, this way. works well. Such crazy. So I need to reposition this. Oh, this one. And the timer stays. That's the world anchor works. Yeah. Okay. So go back to my slides. Okay. So, wrap up. I talked about the placement location updates. Location as well as orientation can be updated in real time, and how to show marker for placement. Also, I talk about the Reality Kit attachment. I explained how to display views created by Swift UI as attachment. I covered also how to use World Anchor. Even though you reset the home location of the apps, you can still maintain the location of the timer. There's more things I can talk about. For example, collision group, that is how to control the tap filtering. Shim phase, app has 3 states. That means active, inactive, and background. We should handle these state changes. And date save and loading. There are the topics I wanted to cover as well. I want to talk about this when I have another opportunity. I hope that I was able to give you some good insights and hints about how to allocate the object within the space. For those of you who have not started VisionOS yet, you might be just following my session, just watching. But actually, if you to go into VisionOS development, I'm sure my talk will be helpful for you. I think VisionOS development is very fun. Let's share our insights together so that we can jointly create an exciting world and universe together. Thank you very much.